Hey there, welcome to MatBytes. I'm your host, and today we have an exciting topic to dive into. We'll be exploring the concept of space complexity in data algorithms and specifically comparing the space complexities of iterative and recursive code for finding the factorial of a number. So let's get started. Before we jump into the comparison, let's define what we mean by space complexity in the context of data algorithms. Space complexity refers to the amount of memory or space required by an algorithm to solve a problem. It measures the additional space used by the algorithm beyond the input data. Essentially, it tells us how much extra memory our algorithm needs to perform its operations efficiently. Now, let's compare the space complexities of two different approaches for calculating the factorial of a number: iterative and recursive methods. By examining their space requirements, we can gain insights into which approach is more efficient. Let's explore the iterative approach. In this method, we used a loop to multiply the numbers from 1 to the given number to calculate the factorial. The iterative algorithm requires only a constant amount of additional space for variables such as loop counter and the result variable. On the other hand, let's discuss the recursive approach. In this method, we break down the factorial problem into smaller subproblems by repeatedly calling the function with smaller inputs. However, the recursive algorithm uses the call stack to keep track of function calls, which results in additional space usage. How? As you can see that the number is passed in the method factorial. Here it checks whether it is equal to 1 or not. As 3 isn't equal to 1, it would go to the else. Here, 3 multiplied by factorial, 3 minus 1 is 2. Now, the function use calls its own method, which is called recursion, and this would continue until and unless this statement comes true. So basically, it would take more CPU usage. Now let's analyze the space complexities of the iterative and recursive approaches. Space complexity is commonly represented using big O notation, which gives us an idea of how the space requirements grow as the input size increases. The iterative approach has a constant space complexity, denoted as big O1. Regardless of the input size, it only requires a fixed amount of memory. In contrast, the recursive approach has a linear space complexity, denoted as big O(n), where n represents the input size. The space required increases proportionally with the input size due to the function call stored on the call stack. Now comes the question, which approach is better? The answer depends on various factors such as performance, readability, and maintainability. In general, for calculating factorials, the iterative approach is often preferred due to its lower space complexity. It uses a constant amount of additional memory, making it more efficient and suitable for larger input sizes. Before we conclude, let's briefly touch upon some other possible approaches to solving the factorial calculation problems. Some alternative methods include memorization, where we store previously calculated factorials to avoid redundant calculations. Dynamic programming, which breaks down the problem into overlapping subproblems, or even leveraging mathematical properties specific to factorials. To summarize, we explored the concept of space complexity in data algorithms and compared the space complexities of iterative and recursive approaches for calculating factorials. We defined space complexity as the additional memory required by an algorithm beyond the input data. The iterative approach has a constant space complexity, big O1, while the recursive approach has a linear space complexity, big O(n). Considering the lower space complexity, the iterative approach is generally preferred to factorial calculations, especially for larger input sizes. Thank you for joining me today on MatBytes. I hope you find this exploration of space complexity and factorial calculation insightful. If you have any questions or comments, feel free to leave them down below. Don't forget to like this video and subscribe to our channel for more exciting tech content. Until next time, happy coding!